Okay guys, so in this video, we're going to be talking about how do we graph exponential functions with a table. So what I did here, I took the liberty of coming up with three random exponential functions, and then we're going to try to graph that using a table. So for that, you might need a calculator to get the numerical result, and that's okay. So I have my calculator handy with me, that way I can use it. Feel free to get your calculator ready, that way you guys can get the final value. Like for example, if your answer is 1 over 17 or something crazy like that, and you want to figure out what that is as a decimal, feel free to use a calculator so you can figure out what that is. Okay, anyways, so let's start with example number 1. So we've got to figure out how do we basically convert this into a number that we can actually graph. So what we're doing here in example 1, 2, and 3 is we're actually plugging in values for x into the function and then trying to see what we actually get as our final result. So for that, we actually need to remember the rules for power. So if you remember the rules of exponents, you should be fine. So for the first one, I have my function, which is f of x equals 5 parentheses 3 to the power of x, right? I'm going to plug it into this one. I'm going to start with the number negative 3. So I'm going to write 5 parentheses 3 to the power of, and then instead of x, my value of x for the first one would be negative 3. So I'm going to replace that with the negative 3. Okay. That being said, I have a negative power. Negative power, if I want to get rid of the negative power, I got to turn it into a fraction. 5 is not a negative power, so 5 is to the power of positive 1, so it stays alone. I'm just going to flip this guy. This actually becomes 5 times 1 over 3 to the power of 3, right? Because if I want to turn that negative power into a positive power, I got to move it to the bottom. And that becomes 5 times 1 over 3 times 3 times 3. Well, 3 times 3 is 9, 9 times 3 is 27. So this becomes 5 over 27, which, like I told you earlier, I don't know exactly what that is, but you could actually figure it out with the calculator. 5 over 27 is 0.185. So I'm going to leave it as 0.19. It's okay to round for these ones. You don't have to write the whole decimal down. Round it if you need to, because when it comes to the graphing, it's not going to matter at the end. You have to approximate anyways. Okay, same idea. Let's do the second one down the list. So we have 5 parentheses 3 to the power of. This time, instead of negative 3, I'm going to plug in negative 2 for x. So x equals negative 2. Same deal. So we want to get rid of the negative power, so we're going to turn that into a fraction. So it's 1 over 3 to the power of 2. Which again, now the exponent is positive, which is what we wanted in the first place. 3 squared is equal to 9, right? So it's 1 over 9. So if I multiply this, it's 5 over 9 in total. Calculator time. So if I want to figure out what that is, 5 divided by 9 is equal to 0.55. So 0.55 repeating, I'm going to leave it at 0.56. All right. Down the list we go. So 5 parentheses 3 to the power of negative 1. Same idea here. We want to turn that negative power into a positive power. So it's going to be 5 parentheses 1 over 3 to the power of 1, which again, 3 to the power of 1 doesn't change it. So it's just 1 over 3. And if you multiply 5 times 1 over 3, again, you just multiply the numerator, not the denominator. So it just becomes 5 over 3. And then 5 over 3, if you want the numerical result for that, is 1.6 repeating. So we can leave it as 1.67 if we round it. Next down the list, so we have 5 parentheses 3 to the power of, this time it's going to be a 0. So I'm going to plug in 0 into there. And this becomes 5 times, anything to the power of 0 gives you 1. And the only thing that's to the power of 0 is a 3. So this becomes 5 times 1, which is 5. Okay, we're getting some progress here. Next one, so we have 5 parentheses 3 to the power of 1. This time I'm replacing the x with 1. So it's going to be 5 times 3, which is 15. All right, next down the list, 5 times 3 to the power of 2. 3 to the power of 2 is not 6. Be careful with that. 3 to the power of 2 is equal to 9, right? 3 times 3. So that becomes 5 times 9, which is 45. All right, I'm going to stop right here because, I mean, I could do the last numerical result. If you want to figure out the next one, the answer for the next one is 135. But I know that it's not even going to fit in my graph, so I'm not even going to bother with it because I know it's not going to be able to fit. So how do we graph this? So if you go down to the graph that I created on the bottom, it's just a generic graph that I put just so you guys can have an idea of how to graph and how to approximate. The very first number we see at -3 is 0.19. 0.19 is super duper duper small, right? 0.19, it's, I don't know, it barely even touches, it barely even leaves the line. So I'm going to put a little dot right there, signifying that it's something really small. On the next one, I have 0.16, so it's really small still. So I'm going to put a dot next to the line, right? Because if you think about it, if 1 square is 2 whole units, what's 0.5? So that's going to be like about quarter or so. Yeah, so I should probably do a better job. So about a quarter or so would be maybe a little bit higher. Okay. At -1, 1.6. So it's going to be 1.5 or so. So if half a square is 1, 1.5 would be about here, 75% of that square, right? At 0, I'm going to have the value of 5. So at 0, I'm going to go up to the number 5, which is right about there. At 1, I'm going to go up to 15. So 1, I'm going to go up to 15 units. Okay, and then at 2, I'm going to go up to 45. Don't freak out if it doesn't fit. Mine doesn't fit. I only go up to 24. So I'm done. All right. You just need to create a sketch of the graph. If you create a sketch of the graph, then you are successful. So I'm going to connect the dots. And the exponential function should look sort of like a ramp. So make it curvy, please. So there we go. So this is my graph of the exponential function described above. So this will be the graph of f of x equals 5 parentheses 3 to the power of x. Okay, so I did example number 1 the lengthy way, basically plugging in, simplifying, getting the value of the function for every single number, and doing it that way. You could also skip, once you get more practice with graphing functions, you could skip a few steps if you know the rules and if you know what the numbers represent. So if you remember one of the other videos, I described this as the y-intercept, right? So the y-intercept is 20. It's also where x is equal to 0. So if the y-intercept is 20 and that's where x is equal to 0, that means that here, where x is equal to 0, we're going to have the value of 20. So I'm going to just go ahead and straight up write 20. Now the number inside, under the x, inside the parentheses, that means we're either multiplying by that number or dividing by that number if it's a fraction. In this case, 1/5 means we're actually dividing by 5. And we always go from the smallest numbers to the highest number. So in this case, we're going from the top of the table to the bottom of the table. So if my number here at my y-intercept is 20, then my next number has to be 20 divided by 5. So 20 divided by 5 is going to be 4. And look, I don't have to do any crazy math or any rules of exponents or anything like that. So I'm skipping all those steps, which is a little bit easier for me. So first number is 20. The next number is 20 divided by 5 if my pattern is divided by 5, right? The next number should be 4 divided by 5, which gives me a decimal. 4 divided by 5, so I'm going to write it as 4/5, which is equal to about, or actually not about, exactly 0.8. If I take that number and divide it by 5, then 0.8 divided by 5 is going to be 0.16. So let's see. So we're going to write it as 4/25, which gives me 0.16. Okay, so anyways, that being said, these numbers, they're from the calculator. If we're dividing by 5 going downwards, then if we're going upwards, the number should be getting bigger, so it should be multiplying by 5. So you get the idea here. If this is 4, 4 times 5 is 20. 20 times 5 will give me the next number, right? So 20 times 5 is 100, so I'm going to go ahead and write 100. The next number should be 100 times 5, which is 500. The next number should be 500 times 5, which is 2,500. So you get the idea. Look, and I did this basically barely even using a calculator, barely even using the rules of powers. But again, if you want to use this method, if you want to skip a step or two, then you have to make sure you're careful and make sure you're very careful with your math. Okay, so let's graph the exponential function. So we're going to start, let's see, the y-intercept is 20, so I'm going to put a dot at the 20. Okay, at the -1, I have 100. I can't even fit that in my graph because my graph only goes up to 24, so I'm going to go ahead and skip that. At 1, I have 4, so I'm going to graph 4. Whoa, that's way down there. At 2, I have 0.8, so at 2, I'm going to be going up to about half of a square or so, close to 1. And then lastly, at 3, I'm going to have 0.16, which is really close to the line because it's a really small number. So my exponential function is going to look like an exponential decay function because it's going down. Notice that it's going down really, really rapidly because the numbers are decreasing really, really fast. So this is what it looks like. Again, it should look curvy like a ramp, so don't make it into a line, please. So this will be the graph of 20 times 1 over 5 to the power of x. Okay, so hopefully you guys are getting the hang of this. Let's do one more just to make sure you guys got it, and then we will be done with this video. So again, it's either way, whichever way you guys want to choose. I'm going to go ahead and choose a little shortcut method just to make the video not as long. So my y-intercept is equal to 1 over 2. So I'm going to write 1 over 2 as my y-intercept here, where x is equal to 0. Now, every single time, notice that it's not a fraction now, it's actually a 4. So we're multiplying by 4. So if this is 1 over 2, which is 0.5, if you're more comfortable with it. So now we're multiplying that number by 4, and that gives us an even 2. So the next one over should be 2. The next one after that should be 2 times 4, which gives me 8. The next one after that should be 8 times 4, which is 32. Okay, so we have our solid number, solid foundation now. So if we want to go up, right, instead of multiplying by 2, because it'll be getting bigger going downwards, we're going to be dividing by, wait, did I say 2? I'm sorry. Instead of multiplying by 4, going downwards, we're going to be dividing by 4 going upwards, right? So 32 divided by 4 would give you 8. 8 divided by 4 would give you 2. 2 divided by 4 would give you 0.5. Now 0.5 divided by 4, if we pop that into our calculator here, I get 0.125. And if I divide that by 4, 0.03. I'm going to leave it at 0.31. And then I divide that by 4. Not that these numbers are going to matter for our graph because they're really, really tiny and we're not going to be able to make those accurate anyways. But I just wanted you to know how we got those numbers. So divide by 4 going upwards, multiply by 4 going downwards. Okay, that being said, can we graph this? So at -3, we have a really, really tiny number. So at -3, we're going to have 0.0078, which is basically touching, not really touching, but like a little above the line. So I'm going to put a little dot right there. At -2, again, I'm almost touching the line. We have 0.031. At -1, I have 0.125. So again, I'm almost touching the line. It's barely anything. At 0, I have 1/2. 1/2 is a quarter of a square. So I'm barely going up still. At 1, I have the value of 2. So at 1, okay, now I'm making some progress. I have 2 as my quantity. At 2, I have 8. So at 2, I'm going to go up to 8. And then at 3, I'm going to go up to 32. If you notice, 32 is out of my graph range. So I really can't do much after that. So if you can't really graph it, don't graph it. Don't worry about it. Just try to sketch the graph. And this is the graph of the exponential function h of x, which we called it 1 over 2 parentheses 4 to the power of x. Now, if you're looking at end behaviors, right, what that means is basically how does this graph behave? So as it goes to the left, this thing goes really, 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 really small. It goes close to 0. As it goes to the right, it goes to infinity. As this one goes to the left, it goes up to infinity, but as this one goes to the right, it goes to 0. As this one goes to the left, it goes to 0, but as this one goes to the right, it approaches infinity. So for end behavior, a lot of the times for the functions that I will give you, it's just going to be infinity or 0. You got to figure out what happens as you go to the left, right? So as x approaches negative infinity, that means to the left forever, so we're going that way. As x approaches positive infinity, that means to the right forever, so we're going that way. Okay? Hopefully this video was helpful. See you guys in the next one.